Hey everyone, thanks for joining. I'm Saurabh Trikande. I'm product manager for SageMaker Inference at AWS. I'm co-presenting with Lee, who's a senior engineer in our team. So we have about 25 minutes. I'll quickly break down the agenda. First, I'll talk about some key trends we are seeing amongst our customers using LLMs. Next, I'll do a quick introduction to Amazon SageMaker and its inference capabilities. Then I'll talk about SageMaker multi-model endpoint and how it helps you deploy thousands of fine-tuned LLMs. Next, I'll hand over the mic to Lee, who will talk about how Totso works in conjunction with MME to enable cost savings for customers. Then we'll do a quick demo and leave 3 minutes for Q&A. Let's get started. Machine learning has become ubiquitous. Our customers are using machine learning in every aspect of their business, from the products and services they build to internal business processes they follow. 2023 has been specifically remarkable for machine learning community. Open source LLMs like Llama are making GenAI more accessible. Number of open source LLMs has grown drastically, and so has their performance. If I look back to October last year, the progress we've made as a community is phenomenal. With all the goodness that GenAI can offer, we are increasingly seeing customers fine-tune LLMs. While some customers are fine-tuning models specific to end users, others are fine-tuning models for a cohort of their users. This has been a trend we have been seeing amongst our SaaS and ISV customers. We also have customers training models specific to a use case or geolocations. When it comes to popular fine-tuning techniques, we're seeing two schools of thoughts amongst our customers. While some customers are using continuous training, which can be expensive, involves recomputing billions of parameters, others are using parameter-efficient fine-tuning, which can be cheaper and involves training only a fraction of parameters. And when deploying fine-tuned models, customers are using accelerators like GPUs and Inferentia. They offer faster matrix multiplication, parallel compute, and seamless support for large models. However, they can be expensive. With tens, hundreds, and thousands of models to deploy, cost of inference can quickly add up. Our customers were looking for a cost-effective way to deploy fine-tuned LLMs. But before I talk about how we solve for it, I'd like to quickly introduce Amazon SageMaker. Amazon SageMaker is a fully managed capability of AWS that helps you build, train, and deploy machine learning models. When you're done training models, Amazon SageMaker offers you a broad range of inference options to deploy your models in production. You can use real-time inference for ultra-low latency predictions or use near real-time inference for asynchronous predictions. You can also use batch inference for offline predictions on large data sets. SageMaker Inference offers you a simple endpoint to deploy all your models. An endpoint can house hundreds of instances behind it, or you could also deploy tens, hundreds, or thousands of models behind the same endpoint. At an infrastructure layer, we give you an option to deploy models on GPUs, CPUs, or go entirely serverless. For model-serving containers, you can use one of our managed containers, like the one we have for PyTorch, or bring your own container. Now let's go back to our problem and see how SageMaker multi-model endpoint helps you solve for it. When you're trying to deploy thousands of models, you have to consider 3 factors. First is the complexity. It could manifest itself as the number of models or the traffic pattern across the models. Next is the cost. This is the infrastructure cost of deploying models or the utilization of the fleet you're already paying for. And the last is the performance. These are your latency and throughput goals. SageMaker multi-model endpoint is a fully managed capability of SageMaker Inference that allows you to deploy thousands of models behind a single endpoint. The endpoint can have hundreds of instances behind it, and all the models deployed on the endpoint use the same instances. SageMaker multi-model endpoints reduces complexity of deployment and gives you the best price performance for deploying thousands of fine-tuned LLMs. Let's see how. Typically, when you're deploying fine-tuned LLMs, or any fine-tuned models rather, you have a skewed traffic distribution or a complementing traffic. When you have skewed traffic distribution, you have a small segment of models that get majority of your traffic. These are the high-frequency models. And then you have a long tail of models that get less traffic, and these are the low-frequency models. In the complemented traffic, your models get peaks at different intervals. Multi-model endpoints uses model cache, which understands your traffic pattern over the period of time and tries to cache frequently used models in memory. Infrequent models are dynamically loaded and unloaded. Next, another theme we are seeing in the fine-tuned models in the LLM space is these models typically use the same serving container. This happens because they're using the same training pipeline, and only the data sets are tweaked. Sharing the same containers across multiple models helps you reduce memory footprint of the container when they're running in production. Multi-model endpoints uses the same container across multiple models to give you the price performance. In case of PyTorch model, this is enabled by TorchServe. To reduce complexity of deployment, multi-model endpoints offers you 5 features. First is the wide selection of instances. You can use multi-model endpoints with 15 GPUs or 32 CPU instance types. It offers fully managed traffic routing, which routes the traffic, incoming traffic, to a healthy copy of model, which could be located on any of the 100 instances deployed behind the endpoint. It also has fully managed model placement, whose sole goal is to give you maximal CPU and GPU utilization. As previously discussed, the model cache understands your traffic pattern and keeps your frequently used models always in memory to give you ultra-low latency predictions, and infrequent models are loaded and unloaded dynamically. Multi-model endpoint also does managed container sharing, where it talks with the model server to instruct it to load and unload model to make sure the instance level utilization is high. Let's see MME in action. Let's say you want to deploy tens or hundreds of PyTorch models which are fine-tuned for different cohort of users on GPUs. In this case, I've taken an example of models that are fine-tuned for different sports. To get started, MME gives you a very simplistic user experience to interact with all your models and update them and deploy them easily. You first fine-tune your models, stage all your model artifacts in S3, create a multi-model endpoint with GPU instances with the artifact location where your models are located. And to get prediction, you simply invoke the multi-model endpoint by passing your target model. Models are cached, dynamically loaded and unloaded, and the request is routed to the right instance, as well as your instance utilization is kept at maximum. This is all managed by multi-model endpoints. Now I'll hand over the mic to Lee, who will talk about how it works behind the scenes.
Okay, let's see what happens when customer call PyTorch models using SageMaker multi-model endpoint. First, client invoke endpoint with targeting models. Second, the smart traffic routing will find the copy of the model to serve the inference request. If needed, the model can be downloaded from S3 bucket. At the compute instance level, TorchServe will be TorchServe as a PyTorch preferred multi-model server. It will load the model on GPU or CPU and ensure high utilization of GPU and the model isolation. While all this happens, model placement will manage model cache and model copies to give you best price performance. With MME integration, customer can enjoy all the goodness that come with TorchServe. TorchServe is a simple, flexible, and high-performance multi-model server. It supports multiple popular machine learning distributed platforms like PyTorch PP, DeepSpeed, and Hugging Face Accelerator. TouchServe offers different batching mechanism to boost inference throughput. It also offers different tools for model analyzer and archiver. It integrates with Touch Compile, Better Transformer, Apex, Onyx, and NeuronX. So TouchServe also supports HTTP, gRPC, and KServe protocol for EKS device. For model loading on SageMaker multi-model endpoint, customer can use the feature like ahead of time pre-compilation and by touch compile and touch export the model. And also user can extend the TouchServe default like a base handler in the initialize function. Customer can use like a deferred initialization for a large model. By using these features, the model latency can be significantly reduced. User can also enhance prediction performance by using features like TouchServe provide continuous batching and streaming response. TouchServe, the continuous batching is very unique. It can cover just a simple template, cover most large language model. TouchServe micro batching can significantly boost the inference throughput by using the large batch size. User can also apply like a better transformer, parallel libraries, and Apex in the pre-process, inference, and post-processing these three functions. Let's take a quick look at the notebook. We will do a demo for deploy 10 models on SageMaker multi-model endpoint and extrapolate this cost saving for like 100 models. This picture shows you the workflow of deploying models on SageMaker using TouchServe. First, we prepare customized handler for the model and define the model configuration. Then we use Touch Model Archiver, create the model artifacts, and upload it to S3 bucket. Then we can create a SageMaker multi-model endpoint, launch the AWS PyTouch DLC container on EC2 instance. Once TouchServe starts, it can load the model. Each model runs in isolated environment. You can see under the same endpoint, the model can be loaded on either CPU or GPU. That means in the mixed mode based on the model configuration. Here, let's see the example for model 1, Llama 2 7B base model. You can see in the handler implementation, we extend the TouchServe base handler. The initialize function, we first apply TouchServe micro batching mechanism to boost the inference throughput. Second, we use the Hugging Face transformer run in low CPU memory usage and 8-bit quantization mode. We also apply better transformer and TouchServe streamer. TouchServe streamer extend the Hugging Face streamer so it can support text iterator on a batch of inference requests. In the pre-process function, we convert the text to a batch of tokens. Inference function will run prediction. Here, we call TouchServe send intermediate predict response for streaming response. So here is the model config.yaml file. It defines the model configuration. You can see we define the number of worker, device type, batching size, the model location, and the micro batching mechanism. The requirements TXT file is a list of third-party dependency. So TouchServe is able to dynamically install third-party dependency on such make a multi-model endpoint in the model isolated environment. Then we use Touch Model Archiver, create model artifacts loaded onto S3 bucket. The model 2 is similar, so I will skip it. Now we are going to create a such maker and multi-model endpoint, starting with model 1, number 2, SMB chat. Once the endpoint, and also it will use such maker PyTorch DLC container. Once the endpoint is deployed, you can see the first model is listed in this endpoint. Such maker multi-model endpoint is able to support dynamically adding more model. Here I added like the other 9 models. Eventually you can see under this endpoint, there are 10 models listed here. Lastly, we can invoke this endpoint. So we invoke this endpoint with the target model, Llama 2 7B base model, run prediction, and get the prediction response. We can also invoke the same endpoint with different model. Here is a Llama 2 7B chat, and get a prediction response. So. How did you? Where is your slide? Okay. So we do a demo for we do a demo for like load the 10 models on such make a multi-model endpoint. If you extrapolate this cost saving to like 100 models with such make a traffic distribution, this table show you like eventually you can get like up to 75% cost saving on such make a multi-model endpoint versus a single endpoint. Before we end, we'd like to extend our special thanks to TouchServe and the PyTorch contributors for the amazing work in 2023. Thank you. We are now open for QA.
Any questions? Currently, it's for CPUs and GPUs. Any other questions? Yeah, so currently marketplace models are not supported, but if you fine-tune your own model or using one of the open source model and then fine-tuning it, yeah, it should work with multi-model endpoints. Yep.
Are you independent of TorchServe, or do you have to use TorchServe?
That's a good question. So the question is, are we independent of TorchServe or do we have to use TorchServe? So multi-model endpoints talks with your model serving container to load and unload models and ensure that your instance level utilization is high. We have support for TorchServe as well as NVIDIA Triton, and we have our multi-model server, which is our proprietary model server that works with it. But yeah, in 2023 we launched it with TorchServe. Any other questions? Oh, Do you mind elaborating model sharding?
Yeah, I mean, multiple nodes and really a single node.
Mhm.
Can you shard it multiple nodes and still be able to serve that request?
So, uh, so if you're trying to load a model across multiple instances, no, that's not supported. Currently, we support like loading and unloading models on a single instance. But happy to hear your use case. Maybe we could chat offline and love to hear what you're trying to achieve. Any other questions? Sounds good. Looks like we're about time. Hey, thanks everyone. Thanks for joining, and hope you have a safe ride home. Thanks.